Welcome to another tutorial. In this particular video, I'm going to have part one of differentiation. Yeah, so I need to write this clearly so that you can be able to see differentiation techniques that you're going to be involved. So we're going to look at questions of different differentiations that you may be able to meet in your course. So this equation here, in order to differentiate this, and something that you need to remember that you're having y equals to x raised to power n, then dy dx is going to be equal to nx n minus 1. So that is exactly what you're going to get. And the moment you differentiate a constant, your answer is going to be 0. So here I'm going to rewrite this equation so that I have y is equal to 2x power 5 minus this can be written as x raised to power negative 1 over 2 plus 3x, so that I remove this square root from down here. So what I'm going to do, I'm going to say dy dx in this case is going to be, this is basically 5. I'll take it down so that it becomes 10 x raised to power 4. I'll take this negative half down to becomes positive, so I'll have this x negative 1 over 2 minus 1, that will be negative 3 over 2. Then differentiating 3x, I'm going to get 3 like that. So basically that's what you do when it comes to differentiation. Then this one here, I'm going to rewrite it first, and this is going to be 2 over 3x minus 4 raised to power 1 over 2. And I can rearrange it further, and it will become 2, rather I'll take it up into 3x minus 4 raised to negative 1 over 2. So with this one, we can be able to perform the differentiation. And to differentiate this, we're going to use chain rule. So this is going to be dy dx. In this case, I'll take the power down without looking at what is inside here. So I'll take the power down and decrease it by 2. So I decrease it by 1. So this is going to be negative a half times 2 will become negative 1 into 3x minus 4 raised to power negative 1 minus 1 becomes negative 3 over 2. Then I'm going to multiply it with differentiating what is inside here. I'm going to get 3, then I'm going to multiply by 3 there. So meaning I treated this as a single term. I applied the power rule. Then now, once I'm done with that, I'm going to differentiate the inner function and then multiply it there. So that we're going to have negative 3 into 3x minus 4 raised to power negative 3 over 2, like that. So we can be able to leave our answer that way. By any chance, you can be able to write this answer like negative 3 over 3x minus 4 raised to power 3, then now square root. You can be able even to write it that way. On this one also, is just the same approach we applied here. We're going to say dy dx is going to be equals to, we are going to assume anything that is inside the bracket, and we're going to say this is going to be 1 over 4 x minus 5 raised to power 2 minus 1, and then I drop my 2 here, and then I'll multiply whatever I get if I differentiate the function that is inside the bracket, and that is going to be 1 over 4. And this is 1 over 4 times 2 is going to be 1 over 2 here into 1 over 4 x minus 2 raised to power 1. Basically 1 over 2 into 1 over 4 x minus 2. We can leave our answer that way. This one we're going to use product rule. We are going to use product rule, whereby we're going to say this is two functions. So we can say the first function is f of x, which is equal to, we can say the first function here is u is equals to x cubed, and the second function is v, which is 4x squared minus 3. So du, differentiating this, just use so I can call this first function f of x equals to x cubed. I can call this second function g of x equals to g of x equals to 4x squared minus 3. Now, I can be able to differentiate this and also differentiate this so that I can be able to apply product rule. So this f prime of x is going to be equals to 3x squared. G prime of x is going to be equals to, differentiating this to be 8x. Now, whenever you're applying product rule, you are going to use dy dx is going to be equals to what? Is going to be equals to f prime of x gx plus g prime of x f of x. So you differentiate one, you keep the other one constant, plus you differentiate the one that you left constant, and then you keep the first one constant. So this one is going to be f prime is going to be 3x squared. Then the function g of x is going to be 4x squared minus 3. Then plus. Now g prime is 8x into bracket g prime of x is that f of x, which was x power 3. And then this is going to be equals to this is going to be equals to, you can multiply here, we are going to get 12 x power 4. This will be minus 9x squared. This time this is going to be plus 8x power 4, right? So this is going to translate to 24x power 4 minus 9x squared as the answer to that. This question here, we're going to use quotient rule, and the quotient rule is where you have d of dx, u over v. This is going to be v du dx minus u dv dx over v squared. So you can identify your u and your v. So our u is actually 3x power 5, and our v is going to be equals to 1 minus 3x. So du dx is going to be 15x power 4. dv dx is going to be, differentiating v, we're going to get negative 3. Okay, which means that our dy dx in this case is going to be v. Our v was this, so we are going to say v is 1 minus 3x times du dx. Du dx is this, which is 15x power 4 minus u. Our u is this, 3x power 5 into bracket dv dx, and dv dx here is minus 3. Then divide by v squared, and our v was 1 minus 3x, and then squared, like that. We can be able to simplify this further. Of course, we can be able to simplify, and this can be what? I can just write it as 15x power 4 into 1 minus 3x minus, now it will be plus, because minus will become 9x power 5 divide by 1 minus 3x raised to power 2. So that is what I can simplify it up to. I can now leave it at that point. So the next question is this: how do you differentiate exponent? Exponent, when you find the y dx of an exponent, you are going to differentiate the power here. You multiply it in front here. So this is going to be 6x. This, differentiating this top, it will be 6x times 4, it will be 24x. Is you write the way it is, like that. You are done. This one, you are going to say dy dx, differentiation of a trigonometric function. You are going to differentiate this inner function you have here. You multiply it by the number that is outside the sign. If there is no number, you multiply by 1. So meaning this is going to be 15 cos 3x. Meaning you differentiate this one, you multiply it outside here, then you differentiate sign. Differentiating sign, you get cos, but you keep what was originally there. And this one, we are going to differentiate what is inside here first. Differentiate this times outside here. So it's going to be equals to differentiating 1 over 14, differentiating 1 over 4x, you're going to get a quarter. Yeah, a quarter times 8 is going to be 2, and this will be, and differentiating cos, you are going to get negative sine 1 over 4x, and the final answer becomes negative 2 sine 1 over 4x. So basically, those are some of the differentiations that you are going to perform. And maybe to bring to your attention, if you are given a trigonometric function that has got maybe if you are given a question like this, let me add question number 9. If you are given y is equals to cos 4x minus 3 raised to power 8, how can you differentiate this? So the first thing that you are going to do, so dy dx, yeah, is going to be, look at the power, don't look at what is inside here. Differentiate normally using power rule. This is going to be 8 cos 7 4 x minus 3, the first thing you have to do. And then now, don't look at the power, differentiate the cosine, it will be minus sine 4x minus 3. Then once you have done that, differentiate what is inside here, also multiply to this, differentiating what's inside now here is going to be 4. So finally, our answer becomes 4 times negative 1 times 8, it becomes negative 32 sine 4x minus 3 cos 7 4x minus 3. And that is the final answer in that case. So whenever you are given powers of trigonometric functions, you are going to do it like that. So you want another one? So that we have the first 10 questions. If you are having y is equals to 3 sine 1 over 8x raised to power 4. So first we say dy dx. To differentiate this, we are going to treat this as a power. Don't look at anything that is here. So we are going to take the power down. It will be 3 times 4 sine power 3, because the power decreases by 1. 1 over 4, 1 over 8 rather, x times. Don't now treat this power. We have already done with it. We look at the sine function. It becomes cosine. It becomes cos 1 over 8 x. Once we have differentiated the cosine, now let's look at this function inside here. If you differentiate it, you are going to get 1 over 8. So 1 over 8 times 4 times 1 times 3. This is going to be equals to 1 over 8 times 3. Write properly. 1 over, write properly. 3 times 4 times 1 over 8 sine power 3, 1 over 8x cos 1 over 8x. Simplifying here, we are going to get 3 over 2 sine power 3, 1 over 8x cos 1 over 8x. So basically, those are the differentiation methods and techniques you'll be using. And if you have found value from this particular video, consider subscribing so that anytime I'm going to upload the next video. See you in the next video. Here we are going to perform implicit differentiation. Implicit differentiation is whereby you equation like this. We are told that the equation is a curve is x squared y minus ay squared equals to 4a squared, and you are supposed to show that the y dx of this curve is. Now, in order to work out the first part of the equation here, remember we are having x squared y, a squared, ay squared, squared. In order to differentiate this term, you see here is a product of x and y. And remember, y is a function of x. So we are going to differentiate this, keeping y constant. So we are going to say this is x, y. And now the second case, we're going to keep x squared constant. We differentiate y. And this is going to be x squared y. Because we are having y, if you differentiate this, you're going to get y. And this one we're going to say minus. Of course, differentiating this, we're going to have these two going down. So it will be a y, then y. Anytime you are differentiating y, you must include the y dx. And this is a constant, so it's going to become 0 at that point. So we're going to put the like terms together with y dx. And basically, this is going to reduce to x squared minus 2ay, then dy x, and then shall say this is going to minus over 2xy. So with this, I can divide these both sides. I remain y, then dx equals negative 2xy. Divide by what? Divide by x squared minus 2a. With this minus, I can be able to rearrange with this equation, and I'll have 2xy over 2ay minus x squared. Because of this sign, I can be able to rearrange that sign. I take it down. I can start by writing 2ay. Okay, so you can see now we have arrived at that equation that arrived. Next part, you are told, hence find the coordinates of the point where the tangent to the curve is parallel to the y-axis. So remember, gradient of y-axis equals to infinity. So meaning the y curve, which is 2xy over 2ay minus x squared, is going to be infinity. How are we going to have this gradient in infinity? Because the gradient of the tangent is equal to the gradient of the curve. If the gradient of the tangent is parallel to the y-axis, it means also the gradient of the tangent, because the gradient of the tangent and the gradient of the curve must be equal. So if the tangent is parallel to the y-axis and the y-axis has infinity gradient, then it means also the gradient of the curve is infinity. So how are we going to get infinity here? Is when the denominator is, therefore we can be able to say 2ay minus x squared. So this is the equation we're going to use, and we shall say therefore for this y is squared over 2a, x squared over 2a. Find the coordinate of that particular point. We are going to substitute anywhere we have y, we're going to substitute this into the original equation. So this is going to be x squared. We are having y here, So we shall replace that with x squared of a minus a into x squared over 2a squared equals to 4a squared. So meaning that if we multiply this, we're going to have a power 4 over 2a minus, if we square this, we're going to get basically a into bracket x power 4 over 4 squared, right? 4 squared. And of course, this will cancel with one of the a's, and then we should have 4 at that point. So once we have this, we can be able to say our expression over 2a minus x power 4 over 4a is equal to 4. If we subtract this, we shall have x power 4 over 4a for this, and this is going to be 4a squared, and of course times 4a times, and this equation here was a cubed, so we maintain a cubed there. This is, I think, writing that cubed, so multiply by cubed, right? I think that is the case. Cubed, so multiply by 4a, this will cancel out, x raised to power 4, a raised to, find the fourth root here, x raised, this is values of, so with these values of x here, we are going to say the first point will be, first coordinate when is 2a, and the second will be when is a. So, but remember y equals to what? Y is equals to a squared over 2a, y equals to x squared, okay, from this equation that we were having here. So substituting the first one here, we have y is equal to a squared over, that is going, basically this is going to 4 divided by a squared, that's, substitute here negative also, so the coordinates where the tangent is parallel to the y-axis, this point. X is equals to ln of 2 plus 3t. Also, we have the equation is y is t over 2. So, in order to get this gradient positive, we are going to focus especially on the first parametric equations. Say this is dy. We are going to differentiate this equation and differentiate this equation separately so that we can combine them again. So we are going to say dx t is going to be equal to, if you are differentiating this kind of functions, you are going to differentiate and use the function that you are having inside it so that you get 3, because if you differentiate this function, you're going to get 3. So it will be 3 over the function that is 2 plus 3t. Managed to differentiate first function. And the second function that we have here, we're going to use quotient rule in order to differentiate it. So remember, quotient rule is a d of dx of v over u. When two functions are divided, this is going to be v du with respect to t minus u dv dt. Then we are going to have what? This is actually t here. Then we are going to have v squared. So in our case here, our u is going to be the top function, which is t, and our v is going to be the bottom function, or the denominator, which is 2 plus 3t. Then du is going to be 1, and dv is going to be equals to, of course, this du dt, and this is dv dt is 3. So if we substitute these values or this expression into this, we are going to get that dv, differentiating this, we're going to get v. V, remember, was this expression, which is 2 plus 3t times du, but du here is 1, minus u was just t times dv. U was just t, but dv is 3. So we shall have our 3 there over v squared, but our v was 2 plus 3t. So we're going to square that. Having worked it up to that point, this is going to translate to 2 plus 3t minus 3t divided by, this is actually squared, 2 plus 3t this and this will out, we end up with 2 plus t. Now, because we need the y dx, is going to be y t times dx. Because we are having the function of t, x as function of t, so meaning that dx dt, if we want the dt dy, we find the reciprocal of this. So this is going to be dy dt is this that we have here, 2 over 2 plus 3t squared times this one here. We are going to find the reciprocal because this is dx and this was dx dt. So we have to find the reciprocal. Have 2 plus 3t over 3. This will cancel with 1 over this expression. So we end up having 2 over 3 into plus 3 as the function there for dy dx. So the first question was, we were supposed to show that the gradient function is always positive. So the expression part is this, and you can see it's positive. So this term is positive, and this 3 plus that. So we're going to say that since 2 plus 3t is greater than 0, you can check whether there is any condition that was needed. Is greater than 0. Since this is positive, therefore the y x, which is equals to 2 of t in 2 plus 3t, is always positive. Now the next question here, we are told find the equation of the tangent to the curve where it intersects the x-axis. So if we are talking about where it intersect the y-axis at y-intercept, x is always equals to 0. So that is what we are going to use here. So if x is 0, it means that x is equals to ln into 2 plus 3t. And x is 0, then it means that ln of 2 plus 3t equals to 0. Then if we find exponent both sides, exponent, we're going to have 2 plus 3t is equals to 1. Then we can take this on the other side, we shall have equals to 1 minus 2, 3t equals to negative 1 divided by 3. Our t is negative 1 over 3 at this case. And remember, we are finding the equation of the tangent. Of course, we are going to check what's the value of y when t is negative 1 over 3. So that will be y is equals to 1 over 3 over 2 plus 3 into negative 1 over 3. This and this out is going to be 1 over 3. This is going to be actually 2 minus 1, which is 1 to the value of 4. So the point where it's going to cross the y axis is a point where we have is the point where we have 0, 3. That is the point where it crosses the y-axis. And then we need to know what's the gradient y dx, what is the gradient of the tangent at the point. And we're going to evaluate dy dx at the point x is equal to. So we are going to substitute that gradient, that value into this so that we can, we said going to be at the point 1 over 3. Dy dx at t is equals to negative. So this is going to be what? This is going to be 2 over 2, that is 3 into 2 plus 3 times negative 1 over 3. So this and this will cancel out. This final, the gradient will be 2 over 3. The gradient of the tangent, that point is going to be 2 over 3. Then we know that the equation of a straight line is y equals to plus c. So meaning that we're able to find the y-intercept. So we are going to say this is y we had gotten it negative 1 over 3, right? Yeah, negative 1 over 3 is equals to negative equals to the gradient, and the gradient is 2 over 3, and then the value of x is 0 plus c. So which means that the value of c at that point is 1. Also, what will mean that will mean that the line is going to be 2 over x 1 3. So next question that we're going to do is how to perform implicit differentiation. So the next question we're going to do how to perform implicit differentiation. We have found value from this video, so that end time I'm going to upload a tutorial. we have been performing different integration techniques, and there's a scenario whereby we need to use this method that is known as integration by parts. And integration by parts formula is actually this formula that we're going to be putting in place. The first thing that I need to bring to your attention, because you are going to decide what's going to be your U and what's going to your V in this integration by parts. And if you are not going to make a wise choice, you may end up getting into trouble. So in order to decide what your U is, in order to know what your U is, we're going to use this acronym that means called LIPET. LIPET, L stands for natural logs, stands for logs. Yeah, can be logarithms. If you see a logarithm, if you see a natural log in your expression that you want to integrate, you can be able to uh, assign it to be U. And if you see um, inverse trig, appearing first there, you are going to assign it as U. If you see a polynomial, you can assign it as what? As U. If you see an exponent, you can be able to assign it as U. And if you see a trigonometry, you can assign it to U. What do I mean? If you are having an integral of ln of x over x, you see we are having integral of ln of x, and then we are having 1 over what? X. We are having two functions here, right? We are having natural log and we are having a polynomial, okay? So which one comes first in LIPET? Log comes first. So you are going to say that your u is equals to what? Is equals to your u is going to be equals to what? ln of x, right? So basically that's what we mean in order to learn this technique of integration by parts. So we are going to focus on two examples. We are going to focus on some of the kind of questions that you're going to look at. So we are saying you are having question 1 here, and question 1 says integrate what? Integrate x e is to x, right? With respect to x. This is one of the questions that we're going to integrate by parts. And when you're integrating by parts, this table is going to be very important for us. So we are going to have a table that looks like this. And in one part, we are going to say this is u, and then this one is going to be dv, okay? Then here we shall have du, and then we're having here v at this given point. So using LIPET on this, we can be able to see we have a polynomial. A polynomial is those terms with powers of x. The power of x here is 1. We have a polynomial, we have exponents. Now, a polynomial, between a polynomial and an exponent, which one comes first? A polynomial comes first. So which will mean that in our integration here, we are going to assign u to be x, but the remaining e is to power x is going to be our dv. E is to x will be our dv. So LIPET enables you to identify u, and the remaining expression is going to become what? Our dv. Now, with x, what is du? Because if you are having u is equals to x, what will be du? Du is going to be 1 dx. If you differentiate x, you are going to get 1 dx. And if you integrate this, you are going to get the same expression there, right? So once you've identified that, remember the formula says what? If you're integrating this, it will be uv. What's your u? Your u is x. Your v is what? E is to x. So we can say x, because our u is x and our v is ex, so we shall say x like that, minus integral of v. What is our v? E is to x. Then we say what? Du. Okay? What's your dv? Then this part here, we are going to multiply. So this is going to be what? This is going to be integral of x e is to x dx is going to be equals to x ex. If I multiply this and this, I'm going to get x ex. And then since I'm multiplying now diagonally, I'm going to subtract. I'm going to do what? To subtract. Okay? So meaning that I will subtract integral of what? E is to x times this is going to become e is to x dx, because that is e is to x times 1 will be e is to x, and then we are having dx like that. So once you've done that, you can see we are having x is to x minus this, but integrating this now, this you see it started with two terms here. Now the term we are having here is 1, so we can be able to integrate this. Integrating an exponent of x, it becomes just an exponent of x, then we shall say plus c, like that. And we are done. So let us see how you can be able to perform this other one. This other one says you are integrating, question number 2, you are integrating x, right? X squared sine x dx. X squared sine x dx. So I want you to tell me, what are you going to assign as your d, and what are you going to assign as your u, and what are you going to assign as your dv? So our u will be what? Our dv will be what? We said we are going to use Lipet. We have a polynomial here, we have a trigonometric function here. So between this polynomial and trigonometric function, which one comes first on the term Lipet? Yes, we can say the polynomial comes earlier than the trig function. So we can say our polynomial, our u is going to be x raised to power 2, and then our dv will be sine of what? Sine of x, right? Now, once we have done that, of course, we can be able to, okay, in order to, we are going to do what? We are going to find dv, or rather, we are going to find du. Differentiating this, we are going to get du is going to be 2x dx. Integrating, because here we are having dv, we shall be going to v, we are going to integrate that. If you integrate this, what are you going to get? You are going to get negative cos x. Yeah, negative of cos x. And we say that we are going to, on this point here, we are going to multiply across, and we're going to say that this integral of x squared sine x dx is going to be equal, multiplying across, we're going to get x squared negative cos x minus, because we shall be multiplying now diagonally here, it will be negative, and we take the negative out, so that will be negative cos x 2x, because this is 2x and this is negative, so it will be negative 2x cos x dx, like that. So if I take this negative out, I'm going to have a positive value there, and this expression will reduce to negative x squared cos x plus integral of 2x x cos x dx. So that is integration by parts. We cannot be able to stop there. Let me just write this properly. This is cos x dx. So you can see again this part that we are having here need to be integrated by parts. There's no way, there's no technique you can be able to use unless you use integration by parts again here. So let us integrate this term. So integrating this term again is 2x cos x dx. Now, again using Lippet, we are going to identify, we shall identify again what could be our u and what could be our dv. We have a trigonometric function and we have a trigonometric function and we have a polynomial. So which will mean also we are going to take our u be equal to 2x, our dv will be what? Cos x. Now with that, we are going to find du here. What will be du? If we differentiate this part, what are we going to have? If we differentiate this part here, we are going to have du is equals to 2 dx, because if you differentiate 2x, you are going to get 2, and integrating this, we are going to get our v being equivalent to sine x. Then normally when we are doing that, of course, what we are going to say is that we are going to multiply across like that, and now our integral, which is 2x 2x cos x dx, will become what? Multiplying this and this, it will be 2x sine x, 2x sine x minus, because we are multiplying diagonally, we subtract. So it will be this times this, it will be integral of minus integral of 2 sine x dx. 2 sine x dx as our term at this given point. Then of course we cannot solve there because we are going to have 2x sine x. Integrating this, it's going to reduce to what? It's going to reduce to, because we are having minus, integrating this term that we are having inside here, integrating a sine, we are going to get a negative cosine. So it will be finally plus 2 cos x, then plus c. So which means that this integral that you were having at this point can be replaced with this part there. Then which will mean our final answer for this particular question will translate what? Minus x squared cos x plus 2x sine x plus 2 cos x plus c as the final integral of this particular part of this question that we are having. Questions which are we are going to integrate forever, like a question that will never end, but we can be able to integrate it the whole day. And this kind of integral is an integral like this one. Let me just show you this integral I'm talking about. You are given an integral of e is to x cos x with respect to x. This integration you can be able to perform the whole day without ending. But I'm going to show you the easy way you can be able to do it by integration by parts. We have an exponent, we have a trigonometric function. Which one comes faster? We have the exponent coming earlier here. So, which means that we are going to say that in our integration, we are going to say that our u is going to be equals to e is to x. And our dv is going to be what? Cos x, right? Now, once we have u and dv, of course, we say that we shall find the u. Differentiating an exponent, you get the same thing, exponent. Integrating cos x to get to sine, it will be actually v is going to be equals to sine x. Then what do we say? Whenever you are using integration by parts with this table, we don't even need to remember the formula, because the integral of e is to x, cos x with respect to x is going to be what? You are going to say it's equals to, you shall multiply across like that. So long as your table you have rearranged it the way you have arranged it here. So you are going to say the answer here will be this and this, it will be a is to x sine of x. Then since you are multiplying now diagonally, we shall subtract and say that will be the integral of a is to x sine x with respect to x. So meaning that we have multiplied this and this, and then we have said with respect to x, because at this point, when you do du, you are going to get du, you are going to get e is to what? Dx like that. It has to be indicated there. Then, again, you can see the integral that we are having at this point cannot be performed by any other method other than integration by parts. So we are going again to perform this integral alone without looking at the rest. Let's perform this one integral by parts again so that we can be able to replace the answer that we shall have here. And that's going to be integral of e is to x sine x dx. Remember, we are going to have u and what? Dv. So this is exponent comes earlier, so we are going to say e is to x here. Du is going to be what? E is to x d what? Dx. And dv, because our e is to x became our u, this one becomes dv. So this is going to be sin x. Integrating this, we're going to get v is equals to negative cos x. Then, as we said, we are going to multiply across and then multiply diagonally. So our expression here that we are talking about will become what? Will become integral of e is to x sine x will, with respect to x, will become multiplying across, it will be e is to x negative, of course, because of this negative sign here, cos x. Diagonally, we shall subtract this, and this will be integral of negative e is to x cos x with respect to x. Okay, then we shall say plus c. All right, because we were integrating, isn't it? Then this is exactly what we were having. We need to do the substitution. So anywhere we are going to have this part, which is basically this one, we are going to replace that with this part that we have. So which will mean that this is going to be what? This is going to reduce to integral of e is to x cos x dx is going to be equals to e is to x sin x minus, in bracket, this part that we have here became this. So it's going to be minus e is to x cos x plus e is to x plus integral of e is to x cos x. Yeah, then we shall say plus c. We can even write it inside here. So then plus c, we can write it there. Then if we open the brackets, if we open the brackets, we are going to take this term and this term, because this times this will be minus. This is a minus and this is a plus. So this times this is going to give us a negative. So if we take this term on the other side of this equal sign, they are going to be two integrals of e is to x cos x dx. So meaning that we shall have two integrals of e is to x cos x with respect to x, which is equals to what? Which is equals to which is equals to e is to x sine x plus, because this and this will be plus, plus e is to x cos x, then we shall say plus c. Because it's a constant, we don't know which type of constant it is, you just say plus c. If somebody I know you start arguing that if this is a negative and this is a minus c, this is a positive c, then should be minus c. No. Because the constant which we don't know, we just say because we are integrating, then plus c. If it's a negative, it will just come out at the end of the day if we were given the limit. And of course, finally, we can be able to say this integral reduces to x cos x dx is equals to 1 over 2 e x sine x plus 1 over 2 is to yeah, plus 1 over 2 is to x cos x, then plus c. Then plus c. Somebody may start arguing that so if we divided by 2 all through, also c will have to be divided by 2. But what I'm insisting and maintaining is that this is a constant. So at the end of the day, we are not going to put a half on that constant, because even if you put c over 2, is also a constant. Now, in order to perform also this integration, of course, we are going to use integration by parts. It's ln over 2x dx. But something that you need to remember is that here we have a 1 that is not indicated here. The one that we're having at this point is just the placeholder. So it means that in limit, we are going to take our exponents as ln of 2x as the value of u, and our dv here is going to be our 1. dv is going to be our 1. So meaning if we are going to find the u here, differentiating this, remember if you are finding d of dx of ln f of x is usually derivative of f of x divided by f of x. Right? Remember that. You differentiate the function that you are having here, divide by that particular function. So basically differentiating this part that we have here, we are going to have what? We are going to have 2 and dividing by 2x, you can see now is going to translate to 1 over x, right? And then integrating this, we're going to get our v equals to x at that point. So we are going now to multiply this and then multiply diagonally, and we said that if you were integrating integral of ln of 2x with respect to x, this is going to translate to x ln of 2x. Then multiplying here, we shall subtract. So multiplying this and this, we're going to have integral of subtract, because we said when we're multiplying the diagonal, we shall subtract it, and that will be 2 over 2x times, remember we're multiplying this and this, times x then with respect to x. X and x will cancel out. This and this will be 1. So this becomes x ln of 2x integral of 1 dx. Okay, integrating 1, what do you get? You're going to get x. So it will be x ln of 2x minus x. Then we shall say plus c. And this becomes the final answer for that particular question. Sometimes you may be required to work out this kind of integrations, whereby you can be able to use integration by parts. You can be able to use integration by parts, but I want to show you how you can be able to use tabular method in order to perform this integration. So the first thing that you need to identify is that we are going to have a table, hence the name tabular. On one part, we are going to have derivative, where you are going to do the derivative, and the other part where you are going to perform integration. And where you are going to perform the derivative is the part which is a polynomial. So this is where you perform the derivative, and this other end you'll be performing an integration. So we shall start with x squared, right? We shall start with x squared. And the next part we shall have here we shall start with positive x squared. We shall be also alternating the signs. And here we shall begin with cos 4x. Now, if you find the derivative of this, we are going to say this will be minus 2x. Finding the derivative of this, we shall say plus 2. Finding the derivative of plus 2, you are going to get 0. So you shall stop there. Here you are going to perform integration. Integrating this part, we are going to get 4 . Integrating this part, we are going to get 1 over 4 sine 4x. Integrating this part, we are going to get minus 1 over 16 cos 4x. Integrating this part, we are going to get minus. All right, performing this integration here, we are going to have negative 1 over 64 sine 4x. So you shall multiply this direct like that. This one multiply to this, and this one multiply to that. So we shall say, therefore, this integral that we were having here, integral of x power 2 cos 4x with respect to x becomes 1 over 4, because if we multiply this and this, it will be 1 over 4x squared sine 4x. This time this will be minus, because this is a minus times a minus, it will be positive. So it will be 1 over 8 x cos 4x. This times this, for this a negative here, it will be minus, and that will be minus 1 over 32 sine 4x, and then you shall say plus c. Basically, that's how you use tabular method. Let me also show you this one. We have a table. What you are going to do to find the derivative will be the polynomial, and what you're going to integrate is this other part. So which will mean that we shall start with x squared, and we shall have sine x. Then differentiating this, of course we start with a positive. Differentiating this, we shall get 2x. We shall have a negative number, because it has nothing to do with this derivative we were doing, but we keep on alternating the signs. And then differentiating this, now we shall say positive 2. Differentiating a constant, you are going to get 0. You stop there. But this one, integrating this, we're going to get negative cos x. Integrating this, we're going to get negative sine x. Integrating this, we are going to get positive cos x, because this is a negative. If you are integrating it, it will be negative cos, but since there was a negative sign, now it becomes a positive. Then we're going to multiply this to this term, this one to this term, and this one to this term. So integral of x squared sine of x is the same as negative x squared cos x. This will be positive 2x sine x, then plus 2 cos x, then plus c as that. 2 cos x, then plus c. Let me just write it down here. Plus 2 cos x, then finally plus c, and that becomes the answer, this one. Okay, in order to work out this question, we are going to learn how to integrate these two expressions that we are having here. And you can see they are involving what we call trigonometric functions. And we shall start by saying, well, this part that we have here, we can be able to relate it to the u. So we can say, let u be equals to sine 2x plus 3. So in order to simplify this further, we are going to differentiate this part and this part. So differentiating u, because u is a function of x, we are going to have du is equals to, differentiating this, you start by differentiating the inner function. So you are going to get basically 2. Then differentiating a sine, we are going to get a cosine. Then it will be 2x. But differentiating this, we are going to get 0. Then we shall write now dx like that. So which means that in this expression here, I want you to see that we are having sine 2x plus 3 raised to power 2 cos 2x dx. But at this point, we are having du equals to 2 cos 2x dx. So I will want to ensure that I'm having cos 2x on one side and only. So meaning that this one we can be able to divide by 2, divide by 2 here. This and this will cancel out. So this will mean that cos 2x dx can be replaced with this part that we are having here, which is a half du. So meaning we shall replace also this one with u, because we had said let u be that. So our integral becomes u raised to power 2, then cos 2x dx, we are going to replace with that with a half du. And this can simplify to 1 over 2 u squared integral du like that. So we can now be able to apply the normal integration technique for polynomials. And to do that, if you are integrating an expression with power 2, you are going to have your u there raised to power 2 plus 1. Then down here we shall have 2 plus 1 as well. Then we shall say plus c. So finally, this is going to be 3, and that will be 1 over 6 u raised to power 3, then plus c. But you cannot be able to leave your answer at this point because the expression was in terms of x. So meaning that we are going to replace the value of u. So it will be 1 over 6 into sine 2x plus what? Plus 3 raised to power 3, then you shall say plus c like that. So basically that's what this expression reduces to when you are performing the integration. Okay, we have this one here, and this one we are going to use substitution, because
if I let, you can see, if I let u be equal to sine x, what am I going to have? If I let u to be equal to sine x, what am I going to have? If I differentiate, I'll have the cos which is here. So that's the objective. I let u to be sine x so that if I'm going to differentiate it, it's going to give me this cos that we have here. Then let's differentiate. To be du is equals to du, differentiating u because it's a function of x, it becomes du. Differentiating sine x, you get cos x dx. So meaning this expression can be written as sine power 4x cos x dx. We can be able to write it this way. Then once we have written it this way, we can be able to substitute because we are having cos x dx at this point. It will mean that if you are having x dx, you can be able to replace it with what? You can be able to replace it with this value that du that we have at this point. So let's write it in terms of u. This will be integral of u raised to power 4 du. All right, because the cos x dx can be written as du. So we have our integral in terms of u. So once you have this, you can be able to perform the normal integration technique for polynomials. So which will mean that this is going to be u power 4 plus 1 over 4 plus 1, then plus c at that point. So once we have this, we can now say our expression reduces to u power 5 over 5 plus c, which will mean that this expression will be u in terms of u, in terms of x, we are going to have 1 over 5 sine x power 5, then plus c. But when it's written like this, we can be able to write it also as 1 over 5 sine power 5 x plus c. Now, that is the final answer for this kind of expression. Yeah, we are going to integrate this. So meaning that we are going to say let u be equals to tan x. Let u be equal to tan x. Then if we are letting u to be tan x, we differentiate both sides. So du is going to be equals to sec squared x dx. Because if you differentiate this, you're going to get sec squared dx. And basically that's what we are having at this given point here, right? So which will mean that when we're going to write this integral, we are going to say it's going to be tan cubed x sec squared x dx. So this part that we are having here can be replaced with du that we are having at that point. Yes. So meaning that we can be able to write this integral in terms of u. So it will be integral of u raised to power 3 because u was tan x. So this one it means is tan x raised to power 3. And then this will be du. Then we can now be able to perform the normal integration technique. So this is going to be u raised to power 3 plus 1. And here we shall have 3 plus 1. Then we shall say plus c. Finally, this becomes u raised to power 4 over 4 plus c. But remember our tan, our u was what? Tan x. So our final answer becomes 1 over 4 tan raised to power 4x, then plus c, like that. So that is how you can be able to use you can be able to use substitution in order to perform this particular question. And if you are finding value from this particular channel, consider subscribing so that anytime I'm going to upload further tutorials, you'll be notified. By so doing, you'll be supporting Proflan so that we can be able to reach more students and those who can be able to benefit more on that. At the same time, when I be creating another video, you will be able to be notified. In Proflan YouTube channel, I do matters physics and math so that I can be able to support you guys as you are doing your O-level and A-level courses, that is Cambridge and edexcel. Now, what about this question here? What about this question here, whereby we are told that cos x squared, we're supposed to integrate cos x squared cot squared x dx. So the first thing that you need to do here is to say, let u be equals to cot x. Then once you have done that, you are going to say du, this one is going to be cosec, negative cosec squared x dx. Now you can see here we are having what is on this part, but the challenge is whatever we are having here is positive, but whatever we are having here is negative. So we shall multiply by -1. We multiply also this by -1. So multiplying it that way, we are going to have negative du is equals to positive what? Cosec squared x dx. Now I can be able to comfortably replace this with whatever I'm having here. So let me just write that integral. It's cot squared x cosec squared x dx. So this part that I'm having here can be replaced with what? Du, because cosec squared dx is equal to negative du. So I'll be able to say, therefore, this is going to be u squared, because cot was just u, so, and this is cot squared, it will be u squared negative du. Yeah, and that will mean that a negative u, I'm integrating negative u, or I can even just integral of negative u squared with respect to u. Then I can be able to integrate this normally to be negative u raised to power 2 plus 1 over 2 plus 1, then plus c, like that. So once we have this, we can be able to say, therefore, this is going to be minus u power 3 over 3 plus c, which is the same as minus 1 over 3 u power 3 then plus c, which will mean what? Which will mean that minus 1 over 3 cot x, of course this is squared, then plus c. But if this squared, no, it's not squared but cubed, but this cubed like this, the same as negative 1 over 3 cot cubed x then plus c as our final answer. Basically, you're gonna just do it that way. So this expression can be written as, we can be able to find du dx. So this will be minus 2x dx. So from here, I want you to notice that I can be able to write this expression that we have here in terms of x dx. And to have 4 here, I need to multiply by -2. I multiply here by -2 as well, so that I'm going to have -2 du is equals to positive 4x dx. So that with this expression that I have at this point, let me show you what I want to write. It will be able to be written as 1 over root 5 minus x squared 4x 4x dx 4x dx. Now this part that we are having down here can be replaced with 1 over square root of u, because we had said u to replace this, and this 4 dx can be replaced with what? This part we have here, -2 du, right? Then we can be able to write this as integral of negative u raised to power -1/2 and then we have 2, this negative 2 here, so we have negative 2 here, and then we have du. If we decide, we can be able to okay, let us just integrate at that point. So we are going to increase this power by 1, so it's going to be negative 2u, negative 1 over 2 plus 1 over negative 1 over 2 plus 1, then we shall say plus c. So which will mean that whatever we are having here, this will be a half, and that will be equivalent to, this will be equivalent to negative 4 u raised to power a half, then plus c. So meaning that our expression will be minus 4 into bracket 5 minus x squared raised to a half, then plus c. So this can be written as negative 4 square root of 5 minus x squared, then plus c, as the final answer of this integral.
In this video, we're going to have this discussion of integration by substitution. How can you be able to work out integral of x into 2x minus 3 raised to power 4? How can you be able to work out x square root of 1 minus x squared dx? And finally, how are you going to work out this with 0 all the way to 1? So I'll show you this, but let us begin from here. When we're talking of u substitution, we can say let 2x minus 3 be equal to u. We are substituting this part with u. So which will mean that u is equals to 2x minus 3. Then we are going to find we are going to differentiate this because u is a function of x. U is a function of x. We are going to differentiate both sides. So we are going to say differentiating this, we are going to get du is equals to 2 dx, like that, because if you differentiate 3 is a constant, it becomes what? It becomes 0. So with this expression that we have here, we can be able to say, with this, we can be able to say du, okay, we can be able to, with this expression, we can say 2 dx is equals to du. Then dx is going to be 1 over 2 du, meaning that anywhere we are going to have dx, we can replace that with 1 over 2 du. And we had also said that this expression that we have at this point here, this expression that we have here, is the expression for u with x. Then from here we can be able to make x the subject and say 2x minus 3 is equals to u. Then it means that 2x is equal to 3, rather it's u plus 3 divide by 2, then x is equivalent to what? X is equivalent to what? X, this x that we have is equivalent to what? Is equivalent to u plus 3 over 2. I want you to look at this if your life depends on this. This expression is very important. Also, this expression that we have here is very important. So we call this dot and this double dot. Okay? So at that point of time, what I want you to do is substitute where you have x, you're going to substitute u. And where we have dx, we are going to substitute du. So this integral that we were having here, which is x into 2x minus 3 power 4 dx, can be written as, anywhere we have x, we are going to write this. So it will be integral of u plus 3 over 2, but this part is basically u, all right? So this is going to be times u power 4. And then we are having dx, we're having this dx, but dx can be replaced with what? 1 over 2 du. Okay, so we are having this constant. Let me just put this. We have this constant and this constant. So this is going to translate to. This is going to translate to. This is going to translate to u plus 3 u power 4 divided by 1 over 2 times 1 over 2 is going to be 1 over 4. Then we have du at that point. So with this, because this is a constant, we can be able to take it outside the integral. So we shall have 1 over 4 integral of. If you multiply this to this, we're going to have u power 5. If you multiply u power 4 times u, I'm opening the brackets here. If you multiply u power 4 times u, you're going to have u power 5. U power 4 times 3, we're going to have plus 3 u power 4. And then we're going to integrate this term by term in the normal, using the normal method of integration. So this is going to translate to 1 over 4, of course. And integrating this, we're going to have what? We are going to have plus 1. So we shall have, let me just put a bracket here. And this is going to be u power 6 over 6 plus this plus 1 becomes u power 4 plus 1 u power 5. So it will be 3 over 5 u power 5 everything. Then we have plus c. Normally we include a constant. So basically this expression that we are having here is going to be what? This time this is going to be 1 over 24 u power 6 plus this and this is going to be 3 over 20 u power 5, then plus c, like that. Now, we were not supposed to leave our answer in terms of u because you know what u was. U was what? This part that we are having here, right? So meaning our final answer is going to be equals to 1 over 24. Checking on there, I'm writing the right place. Power 24. And this is u is 2x, so it will be 2x minus 3 raised to power 6 plus 3 over 20 over 2x minus 3 raised to power 5, then plus c as the final answer of this particular question using u substitution. And also this one that we are having here, of course, this integral can be written as x into 1 minus x squared raised to power 1 over 2 with respect to x. So whatever that we are having inside the brackets here is the one that we are going to let to be our u. So we can say let u be equals to 1 minus x squared. Then that will mean that du equals to, differentiating this, we get du. Differentiating this, we are going to get what? 0, because the constant. Differentiating this, we're going to get negative 2x dx. Okay? So, which will mean that from here, you can see we are having x and dx. So, x dx can be written as x dx is the same as minus 1 over 2 du. I've just divided only by negative 2, both sides, so that I'm going to remain with x dx, which I'm going to replace with negative 1 over 2 du. So this expression that we have at this point, we can be able to say it can be written as 1 minus x squared raised to power 1 over 2 x dx. Yeah, you see now I have x dx, but x dx I'm going to replace it with this part here, and 1 minus x squared I'm going to replace it with u. Okay, yes, u. Okay, yeah, u. I'm going to replace it with u. Then this is going to be integral of u raised to power 1 over 2, u raised to power 1 over 2, and then times negative 1 over 2 du. So I can be able to take this out of the integral. Yes, I have minus 1 over 2 integral over u raised to power 1 over 2 du. Okay, so if I integrate this, what do I get? I'm going to increase the power by 1 and then divide whatever I'm going to get. So this one is going to become minus 1 over 2 times, if I integrate this part, I'm going to have u raised to power 3 over 2 divide 1 divided by this answer that I'm getting, so it will be 2 over 3 here, then plus c. So integrating this part, I'm getting this part, then I'll say plus c. So which will mean that our final answer will be minus 1 over 3, because this and this will cancel out. Shall have u 3 over 2, then plus c. The final answer is with the value of x. But we know x was, u was 1 minus x squared. So we can be able to replace it here. And that will be minus 1 over 3 into bracket 1 minus x squared raised to power 3 over 2 plus c. And this can also be written as, we can be able to write this expression as, from this part is 4 here. Can be written as 1 over, okay, we can be able to simplify this as 3 negative root of 1 minus x squared, x cubed rather, x cubed Yeah, we can be able to leave our answer at this point so that we can be able to move to the next bit here. How can you be able to integrate this? So the first thing that we're going to do here is to say let u be equals to 3x raised to power 3 plus 5. That is the value of u. And then it means that du is equals to 3x squared dx, right? In this expression that we have here, there is x squared and there is dx. So meaning, if I'm having this expression, let me just write it. I'll write with the square root, I can say this is x cubed plus 5 raised to power 1 over 2 x squared dx. So anytime I'm going to have x squared dx, I'm going to replace that with this section here. But this section that I'm talking about, after divide by 3, then we shall have x squared dx is the same as 1 over 3 du. So this part that we are having here can be replaced with 1 over 3 du, this part here. And whatever that is inside this bracket here can be replaced with what? Can be replaced with u, because we have said u equals to x cubed plus 5. Now, our integral with the correct substitution is going to be what? Our integral with the correct substitution is going to be what? It's going to be this part is basically u raised to 1 over 2, and this part here is basically 1 over 3 du. But the limits, I cannot use the limits the way they are, because these limits that we have in here, the limits are for x. These limits are values of x, but we are substituting values of u here. So which means that for the first part, we need to find what this limit is, and for the second part, what this limit is. So let's find the lower limit. Let's say lower u limit. That is going to be, we're going to use the value of x here, and that is u is equals to 0 raised to power 3 plus 5, and that is going to translate to 5. So this limit here is going to be 5. The second limit that we have is the upper limit. And the upper limit, we're going to use this one that we have here. So it's going to be u, the upper limit is going to be 1 cubed plus 5. This is going to be 6. So here we shall have also 6. Now we're going to perform the normal integration of this. And of course, this is going to translate to, we're not going to include a constant here because we have the limits and the constants are going to cancel out. And basically we shall have u raised to power 3 over 2. Yeah. And this is going to be divide by this power that we have. So 1 over 3 divided by 3 over 2 is going to give us 2 over 9. Then our limit of integration will be 5 and 6. So substituting here, we just look for some more place at this point here. I'm showing that when we substitute this, we're going to have 2 over 9 into 6 raised to power 3 over 2 minus 2 over 9 into 5 raised to power 3 over 2. So if we work out this, we are going to get our answer. And put this straight in the calculator. Answer correct to possible calculus will become 0.7815. 0.7815. Okay, the next part that we need to focus on, once you've differentiated, once you've integrated this part to get this one, now the next part that we're going to focus here, once you have substituted this to be the value of u and x squared dx, of course x squared dx is going to be obtained from here. You have du equals to 3x squared dx. For you to have x squared dx, we're going to divide by 1 over 3 both sides. So we shall have x squared dx equals to 1 over 3 du. So any point we are going to have this variable here, x squared dx, we are going to replace that with what? 1 over 3 du. So which means when we are going to have this expression that we are having here in terms of u only, we are not going to write the limit that we were having here. Remember the limits was 0, and the other limits were what? Was 1, and this limit was what? 0. So in order to get the lower limit with u now, you are going to replace 0 in the expression for u. In this expression, we are going to substitute 0 here. So it will be u equals to 0 plus 5. Therefore, the lower limit for this is going to be 5. And for us to find the upper limit, this is the lower limit, of course we have found it. For us to find the upper limit, we are going to use 1 here. So we shall substitute 1 in this part, so it will be u equals to 1 cubed plus 5, and that is going to translate 1 cubed plus 5 is going to be our 6 here. So that we are going to have our limit from 5 to 6 for this one. Then we are going to integrate this. So to integrate this, we're going to increase the power by what? By 1. So to be 1 over 2 plus 1 to be 3 over 2. Then 3 over 2 divided by 1 over 3. Because this is a constant, it can be written in front here. Because if you are having integral of u raised to power 1 over 2, we shall have 1 over 3 there with respect to the u there. So this is 5 and this is 6. Integrating this, we're going to get u raised to power 3 over 2 over what? Over the constant. But this is 1 over 3. So you'll be having 1 over 3 and you'll be having 3 over 2 here. So if you divide these two, that's why we are getting the 2 over 9 from. Okay? So it will be 2 over 9 u 3 raised to power 3 over 2. Then we substitute the limits and our final answer is going to be equivalent to 0.7815. This particular video, we're going to have a discussion on how to perform integrations involving 1 over f of x. For instance, if you are going to be given a question whereby we are supposed to integrate this expression, integrating 1 over x with respect to x, this one you cannot be able to use the normal integration we usually do or the integration that we did. Of course, if you don't do it like this. Don't make this mistake. Don't make this mistake of saying this is the same as integral of -1 with respect to x. And then you say, therefore, this is going to be x -1 plus 0 over -1 plus 0. You see now this one is very wrong. You cannot be able to. Just show you how you can be able to integrate this. Whenever you are integrating an expression like this, this means it's going to reduce to ln of x. This is absolute value of x, then plus c. This is what it reduces to. Now, whenever you are going to have an expression like this one you are going to treat it first so that you make it this way. And you are going to take 2 out of the integral. You will have 1 over x with respect to x. Then at that point, when you integrate this, you can see we have said it becomes this. Then we shall say this is 2 ln of x absolute, then plus c. Now, we want to have a general relation so that we can be able to use it in order to perform a different expression. A situation whereby you are having an integral of 1 of f of x with respect to x, meaning that f of x is a function of x. You are going to say that this is going to be, you are going to differentiate this. You're going to differentiate this function, and you say 1 over d of dx of f of x. So you are going to differentiate this, but you shall say 1 over that, and then you say ln of absolute values of f of x, then you are going to say plus c like that. So I'm going to show you how you are going to use this relation I've told you here so that you can be able to perform integration of this one. So let us go now, we have said the first thing that you're going to do is to differentiate this function that we have here. Differentiating 3x plus 1, what do you get? Yes, we are integrating, but you are going to differentiate first so that you can have what you are going to put 1 over this part. So differentiating this, we are going to get 3. So we shall say 1 over 3, then ln of 3x plus 1, then plus c as that. Now that become right. The next question is for 1 over that. So meaning that this one we have to treat it first, so that because we want a 1 at the numerator, yes, we need to do that. So we are going to say this integral, this integral we are having here becomes what? Becomes 4 integral of 1 over 1 plus 2x. So that is the first thing that we are going to do at that point. I think that pen is faint. Now, in order to integrate this, first we're going to work on this so that we have 1 over a function, then we integrate. So meaning we are going to take 4 out of the integral, so this equation becomes, this integral becomes 4 integral of 1 over 1 plus 2x with respect to x. And since we are having a function of x at this given point, it means we are going to differentiate this. We divide it by 4 here, and this is going to be equal to 4 over, differentiating this, we're going to get 2, then ln of 1 plus 2x, then plus c, which is going to simplify to 2 ln of 1 plus 2x plus c. Now, at this point of time, I want to show you how you can be able to integrate this question step by step. Now, number 1, we need to prepare this question so that we can be able to integrate it using this relation we are having here. First, we have to take 3 outside the integral, and then we shall have 3 integral from 1 all the way to 4, and that translates to 1 over 4 minus 2x with respect to x. That is the first step. Now, step number 2, you are going now to differentiate this part that we are having here. You are going to differentiate the denominator the way we said, then divide by. So we're going to have this as 3. Differentiating this, we're going to get negative 1, negative 2. Then we shall say 1 over negative 2. Then ln of absolute value of 4 minus 2x. Then we shall write the limits from 1 all the way to 4 there. Now, since this is a constant, since this number here is a constant, and it's not going to be affected by these limits that we're having at this point, what we're going to do is to take that constant out so that our expression can be simplified. So this is going to be 3, negative 3 over 2 into bracket ln of 4 minus 2x, like that. Then the limit remains to be 1 all the way to 4, like that. Now this one, we are going to substitute. We are going to substitute 4 anywhere we have x, and then we are going to substitute 1 anywhere we have x here. Then we subtract them. So meaning we are going to have our expression as negative 3 over 2 into brackets. Substituting 4 here, it will be 4 minus 2 times 4. This is going to be minus 8 here. So 4 minus 8 will be negative 4. So the first part will be ln of negative 4. But remember, we have absolute signs there. Then we're going to say minus. Substituting 1 into this, it will be 4 minus 2 times 1. That will be 4 minus 2, and that is going to translate to 2. So this is going to be ln of 2, like that. Like that. So meaning that we have our expression here. So why are we not including the constant? See, the way we were doing in this kind of expressions, we are not going to include the constant because we are having the limits. When the limits are there, don't include the constant because it will cancel out eventually. And this absolute sign means if this is a negative, we are going to treat it as a positive. That's why we are having the absolute values at this given point. So meaning we are going to have minus 3 over 2 into brackets ln of 4 minus ln of 2. Now, from the laws of logarithms, I need you to remember that if you are having ln of a minus ln of b, this translates to ln of a over b from the laws of logarithms. So equally here, we are going to simplify that to a single log, which will mean that we are going to have minus 3 over 2 ln of 4 over 2 over 2 because of this minus sign, which will mean, and our expression is going to become finally minus 3 over 2 ln of 2 as the final answer to this. If you have gotten value from this video, consider subscribing so that anytime I'm going to upload the next tutorial regarding integration, you'll be notified. In this video, we're going to have a discussion how to perform the integration of cos cubed 2x. So to begin with, in our solution, we're going to say let u be equals to 2x, like that. Then meaning that we are going to say du equals to 2, because u is a function of x. When we differentiate both sides here, we are going to have 2 dx, right? So meaning that our dx can be replaced with 1 over 2 du. Then we need to go now back to the expression that we were given. Anywhere we have x, 2x, we're going to replace with. Anywhere we have 2x, we're going to replace with u. And anywhere we have dx, we can replace that with a half du. So our expression becomes the integral of cos 2x becomes integral of cos cubed u times 1 over 2 du. Then we can take this constant outside the integral and we shall have 1 over 2 integral of cos 3 u du. Now, we cannot be able to work with this the way it is this way. We need now to say also let we can be able to write this expression as a half integral of cos x cos u cos squared u du, so that we can be able to replace this with something else. Of course, this can be written as 1 over 2 integral of cos u into 1 minus sine squared u du. Now, at this given point, we can also say let v be equals to sine u. Then we need to substitute. Anywhere we have sign, we're going to put v, but we shall say dv is equals to cos u du, meaning that anywhere we have cos u du, we can replace that with dv. And you can see in this expression that we have here, we can write it as a half integral of 1 minus sine squared u cos u du. So meaning this part can be replaced with dv. And anywhere we have sine u, we can replace that with v. Therefore, this expression becomes 1 over 2 integral of 1 minus v squared, because this is sine squared and v is sine u, so sine u squared will be v squared. Then we shall have dv at that point. Having that, we can now be able to say integrate this term by term, and then integrating this, it will be v minus v cubed over 3 then plus c. So a half here is going to be multiplied to each of these, and I'm going to have my expression reducing to 1 over 2v minus 1 over 6v cubed then plus c, like that. So which will mean that once we have everything well stated there, we remember that v was sine u, right? And u was 2x. So we can be able to say this will be 1 over 2 sine u minus 1 over 6 sine cubed u then plus c. But u was what? 2x. Then we're going to say it's 1 over 2 sine 2x minus 1 over 6 sine cubed 2x then plus c as the final answer of this integral. If you have gotten value from this video, consider subscribing so that anytime I'm going to upload another tutorial, you'll be notified. See you in the next video. Before we perform this kind of integration, let me just tell you, if you're having exponent of x with respect to x, when you are integrating this, it means you are going to say this will be e is to x plus c, just like that, the same function plus c. But if you are having integral of a is to f of x with respect to x, it means that we are going to write the function the way it is here, f of x there, but we shall say 1 over d of dx of f of x. So meaning going to differentiate this function here, we divide by 1 and then we're going to say plus c. If you are given a function and you are integrating f of x with respect to x, you are going to differentiate the power, divide it, then write the function the way it is. So let me just show you what we're going to do here. If we are integrating this, we are going to differentiate the power. If you differentiate 3x with respect to x, we are going to get 3. So we are going to say 1 over 3, then we shall write the function the way it is, then we shall say plus c. This one, we are having 2 over 5. The power is 3x plus 4. So in order to integrate this, we are going to write the function the way it is. Of course, 2 over 5 was a constant. We can take it out and we remain with e 3x plus 4. And then we are integrating with respect to x. So if you are integrating this, remember 2 is just there, over 5 is just there. We are going to differentiate the power. If you differentiate this power, you are going to get 3x. We are having 3x plus 4. Differentiating this power, we are going to get 3. So we shall say 1 over 3 e is to 3x plus 4, then plus c. Because remember, anytime you are doing integration, you must add the c here. So the basic logic here is that whenever you are integrating exponential function, you must differentiate the power, divide it, and then write the function the way it is, then say plus c. E is to 2x squared plus 5x plus 4 with respect to d. Now, first we understand that we can be able to take this constant out, and we shall have free integral of e is to 2x squared plus 5x plus 4 with respect to d. So we have mentioned that whenever you are integrating an exponential function, first you need to differentiate this power. Differentiating the power, we are going to, of course, remember that we were having 1 over 3 times. When you are integrating this, you will differentiate the power and you shall say 1 over what you will get after differentiating the power. And then differentiating this power, we're going to get 4x, and the power is going to decrease by 1, so it will be 4x raised to power 1. Differentiating 5x, we are going to get plus 5. Then we shall write the function the way it was, 2x squared plus 5x, 5x, then plus 4. Then we shall say now plus c. Then now we can be able to simplify this further. It will be 1 over 3 into brackets. Of course, this can translate to 12x plus 15 e is to 2x squared plus 5x plus 4. Then we shall say plus c, which is our constant. Simplifying this, it will be 2 over 15 e is to 3x plus 4, then plus c. That's what it will simplify to, right? And this one, we're going to say we can take the constant out of the integral. We remain with e is to 4 minus 5x with respect to x. And then that means that integrating this, we are going to differentiate this first. And we shall say 4 times differentiating the power. We are going to get negative 5 here. And that will be negative 1 over 5, right? Then e is to 4 minus 5x, then plus c. And then we are done with that. Now, we have question number 5, and question 5, now we are having limits, and then we are supposed to evaluate this. How are we going to go about this one? We're going to say, first, we are going to integrate this, but you see there is a power here. We cannot work it the way it is. First, let's say a is to 4x minus 5 squared. It will be a is to 4x minus 5. Now, if we open the bracket here, we are going to say this is going to be a is to 4x into a is to 4x minus 5, then minus 5 into a is to 4x minus 5. So opening this bracket, we are going to have this equivalent to a is to 8x. This time this will be minus 5 a is to 4x. This time this will be minus 5 a is to 4x. This time this will be positive 25. So which means working out this or putting the like terms together, we shall have e is to 8x minus 10 e is to 4x plus 25. Now this is what we are integrating from 0 all the way to 1, and we are doing that with respect to x. So first I had to expand this so that I reduce this to a value which I can be able to perform the integration. So let me just go ahead and now get some space here so that I can be able to substitute in whatever I have. First, I have to do the integration. Integrating this, we're going to differentiate the power and divide it. So it will be e is to 8x 1 over 8 minus, this one will be minus 10 over 4 e is to 4x. Integrating this, we're going to get plus 25x. So meaning we are going not to include, we are not going to include the constant because we have the limits. So we shall say this is 0 and this is going to be 1 there. So if we put 1 here, the first part of the equation will be into bracket 1 over 8 is to 8 because 8 times 1 minus 10 over 4 e is to 4 because 4 times 1, then plus 25 minus this is going to be 1 over 8 is to 0 minus 10 over 4 is to 0 because 4 times 0 will give us 0 and then plus 0 because 25 times 0 will give us 0. Now this is going to be 1 over 8 is to 8 minus 10 over 4 is to 4 plus 25 minus 1 over n number is to 0 is 1, so 1 over 8 minus 10 over 4, and then we can be able to simplify that. Of course, this is going to finally become 1 over 8 is to 8 minus 10 over 4 is to 4. When we solve this one, simplifying that, what does it give us? Let's check what does it give us if we just work out this one. And basically 9 over 8. This video we're going to do and perform integrations involving trigonometric functions. So something that you need to remember in this case is that integrating cos x, you are going to get sine x plus c. Integrating sine x, you are going to get negative cos x plus c. Integrating sec squared x, you are going to get tan x plus c. So we're going to see how do you use these basic trigonometric tips in order to work out a equation like this. Having a constant here, we can be able to take it out. We remain with integrating cos x with respect to x, and this is going to be 7 times what is the integration of cos x? The integration of cos x is going to be what? Sine x. So meaning this is going to be sine x plus c. So our final answer becomes 7 sine x plus c. If you're given expression like this one, how are you going to work it out in order to perform this particular integration? So first, you need to remember that integrating cos, you are going to get sine. So in that way, we are going to say this is going to be equals to integrating cos, we are going to get what? Sine. So we are going to say this is going to be 2 sine 9x plus 4. Then once you have written that, you are going to differentiate what is inside the bracket. Differentiating this, differentiating 9x plus 4 is going to give you 9. Then you are going to divide that. Then you say plus c. So the first thing you do, you are going to integrate cos, and you know integrating cos, you get sine. Then you write the expression the way it was with whatever that's inside the bracket. Then you are going to divide by whatever you get when you differentiate what is inside the bracket here. And finally, our answer becomes 2 over 9 sine 9x plus 4, then plus c. I believe you're understanding exactly what we did. But if you are integrating sec x squared x, you're going to get tan x. So meaning this one, we are going to say integrating this, we're going to get 3 tan x, but our x is 3x. Then we're going to divide by, because this was not just x like the way we were having x here, we were having 3x. So meaning you differentiate 3x, it will give you 3, then you divide it there, then you say plus c. So the moment you integrate this part, you check what you have here, you differentiate it, then you divide it. So finally this becomes, this and this will cancel out, we end up having tan 3x plus c. Now this one also, we are going to do this integrating sec squared, we are going to get tan. So which means that we can say this will be 2 over 4, the way it is. Sec become tan. We shall write everything with pi minus 2x the way it was. Then we shall divide here by differentiate what we get when we differentiate this part. Differentiating 2 pi, differentiating 3 pi. 3 pi is a constant. When you differentiate a constant, you get 0. Then differentiating 2x, you are going to get negative 2x. You are going to, when you differentiate negative 2x, you are going to get negative 2. Then we shall divide it down here. And then we shall say plus c. But now this is a definite integral. It means we are not going to include that constant there. So we shall say this is 0 all the way to pi. So once we have identified this, what I need to do is to transfer this question here so that we can be able to do it later. Let me transfer it here. This is question number 5. Number 5 was from 1 over 4 pi all the way to a half pi, and we were integrating sine 4 theta, sine 4 theta with respect to theta. Yeah, we shall do that later. So let me just save some space here for this. Once we have done this, I want to simplify it further so that you can see what I'm going to get. This and this will cancel out. I shall have negative tan 3 pi minus 2x over 4, and this is from 0 all the way to pi, all the way to pi. Okay, so the first part, we're going to substitute pi. Anyway, we have x here, so it's going to be minus tan into 3 pi minus 2 pi, because x, we are going to substitute with pi here, and that is going to be, if you if you simplify this, it's going to be something a bit smaller. Yeah, so negative tan, and this is going to be 3 pi, because 0 times 2 times 0 will be 0, so that's going to reduce to that. It will be minus tan pi minus tan pi plus tan 3 pi. So this one we can be able to put straight in the calculator, and when you are doing calculus with your calculator, you have to ensure that your angle is in radians. Ensure that your calculator is in radians when you are dealing with calculus questions. So if I put this negative tan of what you are going to remember is that tan pi to be, basically this term will be 0 and this term will be 0, and the answer for this case here is going to be 0. So we are having this one. Can you perform it and write it in the comment section? Which answer are you getting? Write this, work it out, and write in the comment section the answer you got when you worked out this. Now, the first thing that you ought to understand, that when you integrate this, we are going to have cos 4 theta. Then differentiate whatever you have inside here, you divide it down here. So we are going to do our integration right from 1 over 4 pi all the way to 1 over 2 pi. So meaning we're going to substitute whatever we have into the question. Now, we are not going to include the constant because this we are provided with the limits. Otherwise, if the constant was not, if the limits were not provided, otherwise, if the limits were not provided, you were to include the constant. So we're going to substitute what we know here. We're going to say this minus cos 4 times 1 over 2 pi over 4 minus, into bracket, minus cos 4 times 1 over 4 pi over 4. Of course, this is going to reduce to negative 1 over 4 cos, negative 1 over 4 cos 2 pi minus negative cos, rather negative 1 over 4 cos pi. Now you can be able to put this in the calculator so that you can be able to check what the answer you will get. And I've just reminded you that whenever you are doing calculus, you ensure that your calculator is in radians, not in degrees. So we shall say negative 1 over 4 cos 2 pi the first part here is giving me negative 1 over 4, negative a quarter, negative 1 over 4 minus, if I work out this, let me see what it's giving me. It's giving me a quarter, so this will be 1 over 4. Then if we work it out, we are going to get our answer being negative 1 over 2 as the final answer to this. Is that what you got? Okay.